Bismillahirrahmanirrahim. Today we will discuss about simple harmonic motion, class 10 physics, chapter number 1. So, what is simple harmonic motion? Simple harmonic motion. Uh, what is a simple harmonic motion? So, to discuss simple harmonic motion, we should know about vibratory motion. The to and fro motion of a body about its mean position is called vibratory motion. Or the forth and back motion of a body about its mean position is called vibratory motion. Let's suppose we have an example of vibratory motion here. Uh, Look to this example. This is a pendulum. When we when we vibrate the pendulum at start to and fro motion about its mean position. So the motion of this pendulum is simple harmonic motion. The second example of vibratory motion is uh, the motion of the uh, front of tuning fork. When we vibrate the tuning fork with the help of a rubber pad, it starts to and fro motion. The This is called front of tuning fork. The front of tuning fork start to and fro motion. So this is also vibratory motion. This is also called oscillatory motion. Now we will discuss the second example of a simple harmonic motion, which is called which is now let us suppose. Now how to define simple harmonic motion? So the type of vibratory motion in which the acceleration is directly proportional to displacement and the acceleration is directed towards the mean position is called simple harmonic motion. Now to prove this equation, we take the example of a body of mass m attached to the spring. Let's suppose this is a body of mass m attached to the spring and the spring is laying on frictionless surface. Let's suppose we have this is a table. We have a spring here. When the spring is laying on this smooth surface, so when we vibrate the spring, it starts to improve motion about its mean position. Now let's suppose this is a smooth surface, frictionless surface table. So this is point A. In this point A, the body is in rest. There is no force, so the force is zero. When the force is zero, there is no displacement. X is also zero. When we exert force on the spring, displacement X is produced. This is a body mass M. When we applied force, so the body come from point A to point B. The body come from point A to point B. This is point B and this is point A. This displacement is called X. This displacement is called X. This is Hukla. When the body is released, it again comes back to point A. When the body is released, it again comes to point A and it covers displacement minus X due to restoring force. In this condition, when force is applied and X is produced, this is Hukla, and in this condition, it comes back due to restoring force. So then it starts to improve motion. At this point, it starts to improve motion. Now we have two positions of motion. One is point A, the other is point B, and this is mean position. This is the mean position. So now we will discuss. In this simple harmonic motion, we will also find out potential energy at point B, kinetic energy at point B, as well as velocity at point B, as well as acceleration at point B. Also in the mean position, we will find out kinetic energy. What is kinetic energy at the mean position? What is the potential energy at the mean position? Kinetic energy at the mean position? What is velocity at the mean position? And what is acceleration at the mean position? These are the questions which after when we solve this whole problem, so we can easily find the answer of these questions. Now I want to prove mathematically this equation. So for mathematical proof, let's we have first of all mathematically. So when we applied force on the body, it come from point A to B. So this is Hooke law. According to Hooke law, the extension produced in the spring as directly proportional to the applied force within the elastic limit. We should not cross the elastic limit. If we not cross the elastic limit, the force is the x produced in the spring is directly proportional to the applied force. It means that greater the force, greater will be the x displacement. So to show this relation with mathematical equation, to remove the proportionality sign, we will use constant f is equal to kx. This is equation 1, where k is constant of proportionality of Hooke law. Constant of proportionality of Hooke law. So this is Hooke's law. Hooke's law. Now this is Hooke law at point B. At point B the body is in rest. So when the body is released, it comes back to point A due to restoring force. So the equation, now we can write the equation in such a way: f is equal to minus kx. This is equation number 2. This equation is due to restoring force. Restoring force in the spring. Now to prove this equation, to get this as directly proportional to minus x, according to Newton's second law, F is equal to ma. So put the value here. Ma is equal to minus kx. This is equation 3. To get air from this equation, divide both sides by m. Divide both sides by m. So ma divided by m is equal to minus kx divided by m. M will be cancelled with each other. So a is equal to minus kx divided by m. This is equation 4. In equation 4, k over m is constant and it is called spring constant. K over m is called spring constant. So put the value of k over m in equation 4. So a is equal to minus constant m to x. We will convert the constant into proportionality sign. So a is equal to a is directly proportional to minus x. So we can say that the body of mass m attached to the spring, the motion of this body attached to the spring is simple harmonic motion. It means that in simple harmonic motion, greater the x, greater will be the acceleration. But the acceleration direction is towards the mean position. Acceleration is not directed to the out position, but it is always directed towards the mean position. It is due to minus x. Now, to find out these parameters, so at point B, the body is in rest. Now I want to show you practically with the help of a pendulum. So this is a pendulum. Now this is the mean position. When the body comes to point A, and then release it come back to point B. So at point B, the body is in rest, so the potential energy is maximum, kinetic energy is zero, velocity is zero, as well as acceleration is zero at point B. When the body is released, it come back to from point A to point B at the mean position. At the mean position, the kinetic energy is maximum, potential energy is zero, velocity is maximum, and acceleration is maximum, but the acceleration is negative. So now I want to write these values. So potential energy at point B is a maximum, kinetic energy at point B is zero, velocity at point B is a zero, and acceleration at point B is 0, because at point B the body is in rest for the short time, it come to rest. So these points, now at the mean position, the potential energy is maximum. Sorry, at the mean position the potential energy is 0 because the body is in motion. The kinetic energy is maximum. At the mean position, the kinetic energy is maximum. At the mean position, the body is in motion, so the velocity is maximum at the mean position. At the mean position, the body is in motion, so acceleration is maximum. Acceleration is minus a. Acceleration is maximum at the mean position. Acceleration is maximum at the mean position. That means that the body has acceleration at the mean position, but the direction of acceleration is directed towards the mean position. So these are the MCQs related to this topic. So if you want to solve this topic, first of all you should define the topic. Simple harmonic motion is the type of vibratory motion in which the acceleration is directly proportional to displacement and the acceleration is directed towards the mean position. The second thing is the example. There are two examples of simple harmonic motion. One is the body of mass m attached to the spring. The second example is the body of mass m attached to pendulum. So first we will prove the pendulum. In next lecture we will prove the equation for pendulum. So in this lecture we prove this one. So at point A the force is 0 because the body is in rest, and there is no x, there is no displacement. At point A x is 0. When force is applied on the body, it comes from point A to B, so displacement is produced in the body. So when the body comes from A to B, it obey the Hooke law. So the first equation is, we form the first equation from this one. When the body is released, it come back to point A, and then from A to B, so the to and fro motion is start here. So then it obey the then it is according to restoring force. The second equation become due to restoring force. So this is a Hooke law. F is directly proportional to x. Greater the x within the elastic, greater the force, greater will be the x within the elastic limit. To remove the proportionality sign, F is equal to kx. K is the constant. This is Hooke law. F is equal to minus kx when the body come back due to restoring force. So F is equal to minus kx. This is due to restoring force. According to Newton's second law, F is equal to ma. So put the value of F here. So ma is equal to minus kx. This is equation number 3. So to remove m from this position, divide both sides by m. So when we divide both sides by m will be cancelled. A is equal to minus kx divided by m. So k over m is a constant. This is and called spring constant. So in this, with the here we put constant. So a is equal to minus constant into x. Now we will convert the constant into proportionality sign. So a is directly proportional to minus x. So we can say that the body of mass m attached to the spring, the motion of that body is simple harmonic motion. Now to find out some parameters. So the at point B the potential energy is maximum. At point B the kinetic energy is 0 because it is in rest. At point B, the velocity is 0 because it is in rest. At point B, the acceleration is 0 because it is in rest. At the mean position, because the body is in motion, so at the mean position, the potential energy is 0 because there is no rest. The body is in motion, so potential energy is 0. At the mean position, the kinetic energy is maximum because the body is in motion. Every time the body is in motion, velocity at the mean position is maximum because the body is in motion, and acceleration is also maximum because the body is in a motion. Now, the most important question which you, if I want to tell you that as we know that acceleration, what is the formula of acceleration? So, why the acceleration is directed towards the mean position? This is the question. So, as we know that A acceleration is equal to V divided by T. The rate of change in the velocity divided by time is called acceleration. This is velocity. So, if we find out the value of velocity, so velocity is equal to displacement divided by time. Now we will put the value here. So A is equal to displacement divided by time into time. So displacement divided by t square. So displacement is minus x. The displacement is minus x. Therefore, we can say that acceleration is directed towards the mean position. So if you have any question, you can do in comment section. For more videos, for more physics videos, subscribe my YouTube channel as well as follow my Facebook page. So so all the videos of class 10 physics will be uploaded in this month. Thank you.